Okay, the task at hand is to factor this polynomial. Now, it's not a quadratic, so we can't use quadratic formula or X method. So instead, we are going to work with the concept of the rational roots theorem, which says the following. If the constant term, right, the one without a variable, is Rp, and the coefficient of the term with the highest degree is our Q, then the only rational roots that exist for this polynomial function will be a factor of p divided by a factor of q. All right, what does that mean in practice? And then how do we use it to help us go ahead and break down and factor this polynomial? Okay, let's start by finding all the factors of p. So we've got 1 and 8 and 2 and 4, and that's it. So I'm putting those as the numerator. And then the factors of our q are just 1 and 2. And now what we're going to do is we are going to take each of our numerator factors and put them over our denominator, and then do it again, each of our numerator factors over the other factor in our denominator. So that gives us the following list. So that's each of our numerator factors over 1, and each of our numerator factors over 2. Now, these reduce and several of them double. So 1 over 1, that's 1. And at this point, let me mention that each of these is plus or minus. So plus or minus could be a factor. Okay, 2 over 1 becomes 2, and that will be the same for these next guys, 4 and 8. And all of these get our plus or minus. All right, 1/2 doesn't reduce any further. That's just plus or minus 1/2. 2 over 2 reduces to 1, which we already have. 4 over 2 reduces to 2, which we already have. And 8 over 2 reduces to 4, which we already have. So that tells us that the only possible rational roots to this polynomial could be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1/2. Now, to break into this, we're going to need to do a little bit of trial and error, and the fastest way I know to do trial and error with dividing a polynomial is synthetic division. So let's set up to do that. Okay, so I'm all set to do some synthetic division to test my first potential root or zero here. If you have never done synthetic division, go click on this link and learn how to do this. We're dividing the factor x minus 1 into this polynomial through synthetic division. If you know how to do synthetic division, then let's go. My first step is I bring this 2 down here, and then I multiply. 1 times 2 is 2, and I add. 5 plus 2 is 7, and I multiply. 1 times 7 is 7, and I add. Negative 14 plus 7 is negative 7. 1 times negative 7 is negative 7, and I add. Negative 8 plus negative 7 is negative 15. Now, if this were a root of this polynomial, my remainder here would be 0, but it's not. So now I'm going to go down the line and try the next one. All right, here I go again. Negative 1 times 2 is negative 2, and I add. Is 3, and I multiply. Is negative 3, and I add. Is negative 17, and I multiply. And I can see this is not going to add up to 0, so I move on to my next. And I multiply, and I add, and I multiply, and I add, and I multiply, and I add, and yay! I found my first factor. So one of the factors of this polynomial is the factor x minus 2. Because remember, our factors come in the form x minus h, and what's in here is h. So if this were to say minus 2 in here, then that would be the factor x minus minus 2 or x plus 2, just so you know how to interpret what number worked in here to what factor works over here. Now, I could keep going with synthetic division, right? And keep working my way down the line. But this right here, I started at a 3rd degree polynomial, which means when I divide one factor out of it, I am left with a 2nd degree polynomial, aka a quadratic. And I have a whole lot of really efficient methods for factoring quadratics. So I'm going to go ahead and play around with one of those. You could jump straight to the quadratic formula at this point. I'm going to show you my newest method If you've never seen it before, go check out this video. It's wild and wacky and fast, but it's not quite as intuitive. So go check out the video. Otherwise, again, if you want to just jam it through the quadratic formula at this point, that's fine. But here goes this new method. You ready? My first step, as with the X method, actually, is I multiply my A times my C to get me 8 as my new C. And now I'm going to drop that A, but otherwise write my quadratic just as it was. Now I'm going to go ahead and factor this quadratic. So at this point, you can use the X method, or you can ask yourself what multiplies to positive 8, but adds to positive 9. That looks like 1 and 8. Okay, now I need to take that A that I dropped and divide each of my constants by that A. So that becomes x plus 1/2 and x plus 4. If I am looking at an integer, that is another factor. If I am looking at a fraction, I take the denominator of that fraction and I multiply it to the x there. And those are my fully factored form. 2x plus 1, x plus 4, x minus 2. Okay, are you feeling hesitant about these? Not sure that that actually worked? Let's go back and try it out with our synthetic division and prove it. Okay, if x plus 4 is the factor, remind me again what goes in here? That's correct. The root does -4. Okay, multiply, add, multiply, add. There's that 0. That, in fact, was a factor. And now, if this was x to the third, and this is x squared, then this is x. And there's that other factor. All right, so again, if that method I did at the end there for factoring the quadratic was brand new to you, go check out that video and learn it. It's a really efficient way to get it done. And then this is your example of how to use the rational root theorem. The factors of P divided by the factors of Q give you all the possible rational roots, and it gives you a starting place to start to break down a big polynomial. Okay, check out some of these other videos. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.